Hello all, let us start this project description on a language model chatbot for car diagnostics. The name of this model is Mechanic AI. Now, the main objective of this project is to develop a chatbot that acts as a virtual car mechanic. Now, why have a virtual car mechanic? Now, let me explain this in a scenario where we are at a place, maybe on a highway, where no car mechanic is available and there is a car breakdown. What do we do in such situations? Now, in such situations, a virtual car mechanic can help us, and some temporary repairs we can do and reach a place where repairs are available. That is one scenario. There are multiple other scenarios where virtual car mechanic will be useful. Now, suppose whenever we take a car for repairs and mechanic diagnoses a fault and the mechanic repairs the car, we are always suspecting he has charged properly or he has overcharged us. He may have charged properly, but still that suspicion is there. Here, the virtual car mechanic can help us diagnose the problem. And even if we are going to the mechanic, we will know what exactly is the problem. So with that objective, this virtual car mechanic has been developed. Now, how does it get trained and from where it gets the information to repair the cars? Because we are using a large language model, which is pre-trained, and we have to augment that training with our own data. So we have data in car manuals, service records, and maintenance guides that help us map the problems and diagnose and map the problems to the solution of the problem. So that is the idea behind the virtual car mechanic. We will talk about the technology stack also a bit later. Now, who will be the users of this car? We have briefly discussed on this. In general, car owners, number of cars are increasing and number of repairs are also increasing. So car owners will be happy to have an assistant which is of help like that. Secondly, we have car enthusiasts who would like to do it yourself kind of approach for their cars, customizing cars, repairing cars, and things like that. It will be helpful for them. Then whatever training we give to the model, it will be able to function in that way. Now, mechanics and auto technicians will also be finding it useful. And let me tell you a small story here. When we were young, we used to drive two-wheeler, a scooter, and we had a mechanic who could diagnose problems in the two-wheeler with the help of the sound of the machine, with the help of the sound of the engine. And there was another mechanic who would take hours and hours to find where is the fault in the two-wheeler or scooter, and then he would replace it and repair it. So you see, there is an intricate diagnostic process here, just like an expert doctor diagnoses symptoms to diseases. Similarly, happens in the autos. Whatever is the issue and what is the reason for that issue, and then the cure comes. So mechanics will also find it useful that will help them in diagnosing the problems. In car dealers and service centers will use it for customer support and spare parts ordering and issues and things like that. So these are the use cases and these are the users of the virtual mechanic. Now, what are the key tasks that the virtual car mechanic building has to take place? And one is the important is the data collection, and data will come from car manuals, service records, and maintenance guides. This is a very important step here, and it will be a big challenge to find all this data and gather it together and then feed it into the large language model. Now, directly, the data will not be available in a single format or in a single multi-column table, but it will be available in different formats. So we have to reformat the data, and we have to extract tables also. We have to extract information from the tables also. That kind of jobs we have to do. So Llama Index is the tool which will be doing this job for us, extracting the information and putting it in proper format, and then it is fed into the large language model. So we could use the RAG framework for this, or we could alternatively fine-tune the model. So that much about the data processing and the technology for the virtual mechanic. Now coming to the model training, then we can use the RAG framework for that. We have a foundation model. We attach a RAG framework to it, and then the RAG framework is having all the automobile data, the issues which are there, and what is the diagnostics and what is the solution. So that RAG framework will fine tune the model for the automobile problems. We can use Llama 2 or Llama 3 model for this, or optionally, the same language model could be fine-tuned and it would do the same job. Fine-tuning will be a bit difficult. So RAG or fine-tuning, whichever is the choice, what type of challenge students want to take, accordingly, they can choose whether they will use RAG or they will fine-tune. And the focus area is here to recognize the patterns that can map the symptoms with the possible issues, and from the issues, what are the solutions that are going to be there for the cars or for the two-wheelers, whichever we are choosing. Now, to evaluate the model, we have to have all the issues. That will be very exhaustive. So we will have 3 types of issues here, which it will be diagnosing. It is engine issues and the transmission fault issues and electrical system failures. These are the 3 areas that we can work on. If there are other areas for which data is available, that can also be done. And also there has to be a refinement process that based on the diagnostics and the repairs done, a customer feedback is taken and the model has to be given a feedback and it should improve over the time. So that is the refinement process that has to take place. Now, an additional challenge has been given in this project, which is ordering of the spare parts. Now, whether the spare part is available in the market or not, what is the cost of the spare part, and ordering for the spare part. That is the challenge that is added to this project. And for this, we have to use the agent framework. Now, when a person may be lost in some highway where mechanic is not available, so a mobile interface is very interesting for this and very useful for this type of scenarios. And therefore, a mobile interface is the additional thing that has to be done with the along with this project. It will be very useful for this project. And finally, we are coming to the tech stack. The tech stack is the usual front end and back end, which is the MERN stack, HTML5 and React.js, Node.js and Express.js. That is the MERN stack that can be used. For machine learning AI, the large language model, Llama 2 or Llama 3 can be used. A RAG framework can be used, and Hugging Face libraries and transformers can be used, or we can fine tune the model, whichever is the choice. Agent framework is also required here, and LangChain may be used for that along with other tools. Mobile interface, as we discussed, is also important. So React Native or Flutter can be used for the mobile interface. That is about the tech stack that we will be using. So finally, we will have a chatbot which will diagnose car issues using manuals and service records. That is what we are going to do. And it will use Llama 2 or Llama 3 language model along with RAG, or it can fine tune the model. Agent framework will help ordering for the service spare parts that are required for the repair purpose. And looking forward, the plans ahead are to give feedback from the user to the model so that improvement in the model can take place. So that is a brief description of the virtual mechanic, and it has to have data for diagnostic of issues and possible solutions. It will use RAG or fine-tuning large language models, and it will use agent framework. That is the virtual mechanic that is there for the students. Thank you.